Welcome to Unit 4, where we'll focus on rearranging formulas. This is a key skill, especially for those of you sitting the higher paper, where marks are awarded for correctly manipulating equations. Mastering this will help you secure those top grades. Here's a typical GCSE exam question. At this stage in the course, you should feel confident selecting the correct formula and converting any non-standard units. However, in this case, current isn't the subject of the formula that we need to use. To solve this, we must rearrange the equation to make current the subject. Many students find this challenging, but by the end of this lesson, you'll be able to approach these questions with confidence. In the FIFA method, we tackle rearranging formulas during the fine-tune stage. You might have been taught to rearrange formulas as the first step, and that's absolutely fine. However, the reason we use the FIFA method is because examiners award marks for correctly substituting values from the question into the formula as given on the datasheet. So even if we rearrange incorrectly, we will still pick up some marks. And that's why we are going to input our values first before rearranging. Before we apply this to exam questions, let's practice the skill of rearranging in isolation. You can download the task below or find it as part of the course workbook. I'll model the first 3 examples, then you will have a chance to try it yourself. What the focus of this activity is to make the thing that we are being asked to calculate the subject of the formula. Question 1. Our goal is to make the unknown value, represented by the question mark, the subject of the equation. This means rearranging the formula so that it stands alone on one side of the equal sign. To do this, we first ask, what is currently happening to the unknown value? In this case, it's been divided by 0.8. To isolate it, we need to undo this operation by using the opposite function, also known as the inverse function. Now that sounds harder than it is. There's a lot of maths words. All we do is we just do the opposite thing that's happening to it. The opposite of dividing by 0.8 is multiplying by 0.8. And since an equation must always stay balanced, we apply this operation to both sides. So we end up with 400 multiplied by 0.8 equals the unknown value divided by 0.8 and multiplied by 0.8. Now, here's the key idea. If you multiply and divide by the same number, you always get 1. So for instance, 0.8 divided by 0.8 is 1. And anything multiplied or divided by 1 is the same. For instance, 10 divided by 1 is still 10. 10 times by 1 is still 10. So we can ignore this step and simplify by cancelling out the opposite functions that appear on the same side of the formula. So our formula now reads 400 times by 0.8 equals question mark. That's pretty straightforward and it's easy to solve. Now the unknown value is isolated and we have successfully rearranged the equation. You'll get really confident at doing this. It will just require a bit of practice. The more that you do, the more confident you will feel with rearranging. It might feel a bit tricky at first and it might feel like there's a lot going on. But with practice and repetition, you'll understand exactly what to do each time. So the goal of this task, remember, is not to solve the formula. We'll skip this step and just focus on rearranging for now. Question 2. This time, the unknown formula is being multiplied by 9.8 and 0.5. So before we rearrange, it's good practice to simplify the equation first. Simplifying reduces the number of terms in the equation, making it look less overwhelming and easier to work with when rearranging. To simplify, ask yourself, is there a calculation that could be done first? In this case, yes there is. We can multiply 9.8 by 0.5. And now our equation becomes 620 equals 4.9 times by question mark. That's a lot easier. Looks a lot less complicated. From here, we can rearrange just like we did in question 1. To isolate the unknown value, we apply the inverse operation. Since it's been multiplied by 4.9, we divide both sides by 4.9. And we end up with 620 divided by 4.9 equals the question mark. If you're confident with rearranging, you might choose to skip the simplification step and divide by the entire expression in one go. Divide both sides by 0.5 times 9.8. Let's pop that in brackets to keep that expression together. When we rearrange and cancel out, we end up with 620 divided by bracket 0.5 times by 9.8 close brackets equals question mark. Both methods lead to the same answer. Just pick the one that works best for you. Question 3. This question's a little trickier because the unknown value is the denominator of a fraction. To solve this, our first step is to eliminate the fraction by multiplying both sides by the unknown value, bringing all the numbers to the same level on the equation. So if we do this, we end up with 1.7 times by question mark equals 800. Now we can rearrange as before. The unknown value is being multiplied by 1.7, so we apply the inverse operation, dividing both sides by 1.7. And we should end up with question mark is equal to 800 divided by 1.7. Now it's your turn to test your understanding and see if you're ready to move on. I've tried to show you 3 different examples of rearranging, and most rearrangements that you have to deal with can be solved by one of these methods. So pause the video and use the models to try and help you answer questions 4 and 5 on your own. I'll reveal the answers following the countdown. Remember, you're not trying to solve, you're just trying to rearrange. Now that you've practiced rearranging formulas, let's combine this skill with everything that you've learned so far in order to tackle some challenging exam questions. I'll walk you through 2 examples step by step before you try it on your own. Make sure that you're working along with me, showing all of your working out, so that if you do make any mistakes, you can find exactly where you've gone wrong. These questions are available to download below, or they're available in the course workbook. Let's get started. By this stage of the course, you should know exactly how we're going to start. First, let's highlight all the values given in the question and box the subject that we need to find. In this case, we've been asked to calculate mass, so this will need to become the subject of our formula. Before we go any further, let's check that our values are in standard units. After Unit 3, you should feel confident recalling these, but if you're unsure, there is a reference table in the course workbook. Knowing these units prior to your exam is absolutely essential, so keep working on recalling them. 0.4 newtons is a force, and newtons are the standard units of force, so there's no need to convert. 1.6 meters per second squared is the acceleration, and that's also correct, so no conversions are needed here either. Now, let's apply the FIFA method to guide us through solving this equation, F for formula. We need to use the physics datasheet in order to find a formula that links acceleration, force, and mass. You should be getting quite familiar with doing this by now, but if not, go back to and review Unit 2. The formula that we need is force equals mass multiplied by acceleration, or F equals ma. Remember, if you write it in symbols like I have, be careful to get the case correct. I input the values. So we're going to substitute the values that we've highlighted earlier into our formula, making sure that if we've done any conversions, it's the converted values that we put in. So force is 0.4 newtons. We don't need to put the newtons in. The mass is unknown, so we'll leave that as m. And the acceleration is 1.6 meters per second squared. And this gives us the equation 0.4 is equal to m multiplied by 1.6. At this point, we've already secured ourselves 1 mark in the exam, just for correctly inputting the values. And that's why I always recommend writing out the equation exactly as it appears on the data sheet before attempting to rearrange it. If you make a mistake without this step, you could lose all of the marks for this question. Next step is to fine tune. So what we're going to do here is make mass the subject of this equation. First, ask yourself, what is happening to mass currently? Or right now, it's being multiplied by 1.6. So to isolate mass, we need to do the inverse operation to cancel it out. The opposite of multiplying by 1.6 is dividing by 1.6, so we apply this to both sides of the equation. Our equation now becomes mass is equal to 0.4 divided by 1.6. The next step is A for answer, and now that mass is the subject, we're ready to solve it by entering these values into our calculator. 0.4 divided by 1.6 equals 0.25, and this is the mass, so it will be in kilograms. Always double check your calculation, and once you're happy with your final answer, let's pop it on the answer line. Let's do one more together before you try some questions on your own. As always, we start by highlighting the values given in the question and boxing the subject that we need to find. In this case, we're going to be solving for current. Before we move on, let's check whether any conversions are needed using our knowledge of standard units. First, we can see that we've got 2.76 kilowatts, and this is the value of power. However, power should always be given in watts, so we'll need to convert this. To do that, let's write out the conversion factor as we practiced in Unit 3 of this course. Kilo means 1,000, so 1 kilowatt is equal to 1,000 watts. Since we're converting kilowatts to watts, we need to make the value 1,000 times larger, and we do this by multiplying by 1,000. So 2.76 multiplied by 1,000 equals 2,760 watts. Make sure you write out this conversion clearly, as there will be a mark awarded for this step. Also, cross out the original values to avoid accidentally using it later on. It's really common for students to do this. Next, the other value, 230 volts, represents potential difference. Volts is already the standard unit, so there's no need to convert here. Now we're ready to apply the FIFA method to guide us in solving the rest of this question. Let's start with F, the formula. We need to find the equation that links power, potential difference, and current. So let's turn to the physics datasheet and locate the correct formula. The formula that we need is power equals current multiplied by potential difference. Next, let's input the values. Power is 2,760 watts. Current is unknown, so let's leave it as I. And potential difference is 230 volts. This gives us the equation 2,760 equals I times 230. Just like before, we have now secured a mark for correctly substituting values into the formula. And we also secured a mark for doing a conversion. So we've picked up 2 marks already. Make sure, again, you do not skip this step. Many students do, and they risk losing all of the marks for the question if they rearrange incorrectly. F stands for fine-tune. This is where we're going to actually do some simplifying and rearranging. We need to make current the subject. To do this, ask yourself, what is happening to current, I, in this equation? Well, right now, it's been multiplied by 230. To isolate current, we do the inverse operation to cancel this out. The opposite of multiplying by 230 is dividing by 230. So we apply this to both sides of the formula. And this leaves us with a rearranged formula of 2,760 divided by 230. Finally, A stands for answer. So now that we've got our rearranged formula, where current is the subject, we can enter into the calculator and find the answer. 2,760 divided by 230 gives us 12. And this is a current, so it's going to be 12 amps. As always, double check your calculation, and once you are happy, write your answer on the answer line. Now it's your turn. If you've completed these activities and worked along with me, you should be feeling much more confident in rearranging formulas. When you're ready, mark this section as complete and move on to the independent practice lesson, where you'll apply everything that you've learnt so far to 2 exam-style questions. Remember, you can revisit this video at any time. Be sure to show all your working, just like in the model, so that you can compare your answers to my solutions and easily spot any mistakes. Good luck, and I will see you in the next lesson.